Hello and welcome to lesson 2 of week 10. In this lesson, we're going to look at backup and restore, and then we're also going to look at how to maintain our tables in MySQL. My name is Mildred. Now, to back up MySQL, we need to know how to do certain things, and there are certain tools that we use. But why do we actually need to back up our data? Well, we need to protect our data. We need it for recovery. We need it for migration, okay? And we have several methods that depends on the size of the database or the downtime tolerance or the needs for that backup. There are different types of MySQL backup. The first one we're going to look at is logical backup. And for logical backup, you just export database objects like the tables, the schema. If you have triggers, you have stop procedure, you export all of these as SQL statements. Alright. And so the tool we use here is MySQL dump or MySQL pump. So let's look at how we can do that and export our database to any location of our choice. For instance, I want to log in as an admin, so let me say MySQL u root p and put the password. Now if I say show databases, I have this classic models database, so this is what I want to export. So I'm going to exit from here and I want to export this to my desktop, right? So I'm going to navigate to my desktop and I'll say cd desktop like this, and if I list the files on my desktop, I can see that I don't have my SQL file, so I can go back out to my root directory here. Now I want to use a logical backup and I want to use my SQL dump tool to take all of my classic models file and dump it on my desktop. So the advantage of this is that it is portable, it is human readable, it can restore on different MySQL version platforms, and the disadvantage is that it's slow for very large databases. So you do my SQL dump and then you specify your username, root, your password, and then the name of the database that you want to export, so it's classic models, and then you use a greater than sign and the directory. So I want it to go on my desktop because I'm not currently on my desktop, so I want to navigate to my desktop and I want to store this as, let's say, classic models.sql. If all is well, it is going to ask me for my database password and then it gives me the next cursor, which means it's likely done. When we navigate to desktop and I list, I can now see classic models.sql exported here. So I have the whole thing dumped here. So now I have it there and I can easily now restore this database and all the tables and data in it if I have any problem. You can actually do this in your CI/CD pipeline or in your maintenance automation where you run this periodically, MySQL dump, and you look for a location to dump them. You can dump them in different formats. That is for advanced course. We also have the physical backup where you get the actual copies of the database files like the .ibd file, .ib data logs and all that, and the tools we use for this is MySQL hot copy. So our database engine here is InnoDB. We're using my ISAM, we will use that, and then this kind of backup is like a file system level backup. All right, we can use also the Pecona extra backup. Advantage for the physical backup is how fast it is for large databases and how much it is fast for point in time recovery. Then the disadvantage of that is it is not portable. If you want to restore this, you must restore it to the same MySQL version and the same engine. And how you do that is to use extra backup like this, backup user, and then you specify is equal to username, password is equal to password. Then so let's say user is equal to username, I'll just specify everything here. Password is equal to, you put your password, and then you have target directory like this is equal to, and then you put the directory, so you put the path to file. So we have the full and the incremental backup, and the full backup is when we back up the entire database every time, and incremental is when we back up only changes since the last backup. So often do this with binary logs or extra backup. So we can classify the type of backup into hot or cold backup based on the database operational state during that backup process. Hot backups are performed while the database is actively running and serving requests, and this method ensures minimal disruption to users during the backup process. Cold backups are performed when a database is offline and no writes are occurring, right? So we can use the MySQL dump, and we use that to back up a single database. We can also use that to back up multiple databases, and we can do that like this. So instead of having only classic models here, let's say we have several databases, I'll just name them database 1, database 2, and so on. So I can say DB1, DB2, and it's going to be a space separated list, DB3. So all of these DB1, DB2 represent the names of the database, and then you put a greater than sign and then your directory and the name of the file where you want to back that up. You can back up all your databases by using this flag. So if you use your P flag and then you put the all databases like this, and then a greater than, and then the directory or the name of the file you want to save all the backup in. If you want to back up with schema only, no data, you want to instead of all databases here, you change this to no data. So you just want the schema only, then the name of the database, and put database name here. Alright, so the name of the database. You can use MySQL pump, which is faster, and you can just replace MySQL dump with MySQL pump here, and its remaining is the same syntax. You just change here to MySQL pump P and then databases and then your database name here, DB name here. And then we can also copy the data directly from the MySQL when you stop your MySQL server. So when you want to stop your server, you use system control. So you do systemctl stop MySQL like this, and this will stop your MySQL. And then once it's stopped, then you can now use, I don't want to stop MySQL, so I'm going to just use the copy command. So you do cp, the R flag, and then the directory there that you want to back up, and then you start back MySQL, and you just do systemctl start MySQL like that to start back your MySQL. So if you want to use the binary log based incremental backup, you just enable binary login in your configuration file, and then you take so you do it like this. You say MySQL bin log MySQL bin, and then the name of the binary log file. So let's say MySQL bin dot. So you see the file when we looked at it in the last lesson, and then you specify the name that you want it to save the file. So this will allow you to use point in time recovery. So for when you want to restore, you can restore in similar way, but instead of the greater than, you use the less than sign. Okay, so now we'll do MySQL U. I'm logging in as a root user P, and then I want to put the name of the database. So let's say my database here, and then less than sign, and then the name of the file. We have classic models on the desktop, so this will go to desktop / classic models, okay, .sql. So you can restore like this from a file you have on your system or on another server. But if it's from multiple databases, you don't specify the database here, the name of the database you want there. You just leave it like this, and then you put the file that you downloaded. And if you want to do that with binary log file, the same way we just looked at for the backup, is the same way you restore. You use MySQL bin log, and then you specify the file name. Let's do it like this: MySQL bin log. Specify the file name. Let's say the file name is MySQL bin. So you have to go back to the previous lesson to see how we got the name of the binary file. You use this sign, and then you log in MySQL U root like this, and then you use that to restore from the binary log file. If you want to restore a physical copy, you stop MySQL, you replace the data directory, and then you fix the permissions. Alright, and then you start back MySQL. So your best practices for backup and restore is to schedule regular backup, maybe daily full backup or incremental hourly backup, especially for critical systems. If you have banking system, health system, you want to incremental hourly backup. You want to test the restore process periodically. A backup is useless if it cannot be restored, so you want to periodically test your restore process. You also want to store your backup securely. If you want to encrypt or restrict access to the location of your backups, you want to keep your backup off-site, or you want to do some cloud backups to protect against your server loss, and you want to use replication for maybe high availability in addition to the backup. So in summary, we look at the tools that we use for logical backups. MySQL dump is one of the best, portable and simple. You want to use MySQL dump or pump. You want to use extra backup if you are doing a physical backup or large databases, and if you want to have minimal downtime. If you have binary logs, you want to enable point-in-time recovery, and if you want to restore, you can use your MySQL to dump and replace files from the physical backup. So for those of you who move on to be a database administrator, you will have to go deeper in these topics and test them and try them. All right. The last topic we are going to look at in this course is the table maintenance. We have seen how we create tables, how we perform queries on table. What if we want to check and see if this table is actually running properly, there are no errors, and we want to check just the integrity of the table and there is no corruption? Let's log in. MySQL U root P, and now for this I want to say, let's say use classic models, use classic input class. Now we are using this, and let's say we want to check a table here, so use check table statement, and let's say I want to check the table orders. So I will see the table orders, check message type status, message text okay. So this is what you will return when you check. If I want to check more than one table, let's say I want to check the orders table and the comma separated list, the payments table, like this, and now I see both of them and their status okay. Alright, there are other options you can use. You can check quick, check fast, check change, check extended. So maybe I say this and I put extended like this, so we'll get the same out. We can use other values. Let's say we want to check change and we have it like that. So when we use quick, we get faster minimal checks. If we do fast, we only check tables that are not closed properly. So when we use, like, instead of change, we use fast, we'll look at only tables that are not closed properly. When we use change, we'll only check tables that changed since the last check, and extended, we do a thorough check. When we want to repair tables, we use the repair table statement like this, repair table, and then we specify the table name there, and then we have the options quick, extended, or use .frm. Okay, so we use frm, that uses .frm file for table structure if the my is missing. So let's say repair table customers, and we use the quick option, and so we look at this. The storage engine does not support repair, and when we want to do this, it only supports for my ISAM or archive. No, it's not needed for InnoDB because it handles recovery automatically. When we want to optimize table, we use optimize table, table name, optimize table, and then the name of the table. Let's say optimize table orders. And what this does is reorganizes the table storage and defragments indexes to reclaim space. That's what it does here. So it doesn't support optimize, doing recreate plus analyze instead. Okay, so it does that. Okay, so you have to see what is supported for your storage engine. We are using InnoDB, and some of these things are handled automatically for InnoDB. So if we are using InnoDB, it alters the table and it forces internally to rebuild the table, but my ISAM will defragment the files. When we want to analyze a table, we can say analyze table and then the name of the table. Let's say we want to analyze table orders like this, and then we'll see operation analyze okay like this. All right, so we can analyze the table like that, and we can run a table maintenance by using MySQL check, and this is a command line utility that allows you to check, repair, analyze, or optimize multiple tables or the database without shutting down MySQL. And we can do this even when we are logged out of MySQL. And so when we log out, what we can do here is to say, let me say exit, and I want to check, so I'll do MySQL check like this, and I'll run user root password optimize. I want to optimize classic models like this, and so it will ask me for my password, and then it will check this and it will tell me it does not support it, doing recreate plus analyze instead. And so it checks all of the table and then it does that. So in summary, we use the check table to detect corruption in our table. To repair the table, we use repair table statement. This only works for my ISAM and archive storage engine, and it fixes their corruption. We use optimize table to defragment and reclaim space. We use analyze table to refresh index statistics, and we also use MySQL check to automate all of these tasks across multiple tables. So when you want to build this into your back end or into your tools, development tools, you want to think about all of the things you want to automate in your database. So this is where we end this lesson, and congratulations for coming to the end of my SQL Fundamentals course. Thank you, and hope to see you in an advanced course.